Lesson 2-1, Integers and Absolute Value. When we are referring to integers, we are referring to the set of all whole numbers and their opposites, as well as 0. On the number line, all of the integers located to the right of 0 are called positive integers. These are also known as our whole numbers. And we use the plus sign to represent these positive integers. All of the integers located to the left of 0 on the number line are called negative integers. And we use the minus sign to represent these. Right, so we can really just think of integers as all of the whole numbers and their negative counterparts. Right. So now, one thing that we have to keep in mind when comparing two or more integers is that on the number line, as we move to the right, the further we move to the right, the greater the numbers become, the integers become, right? So we can say the integers increase in value. They become more positive as we move further and further to the right. Okay, the opposite is true as we move to the left. So as we move further and further to the left, the more negative the integers become, which means they become smaller. So the more negative an integer is, the further to the left of 0 an integer is, the smaller the integer is. Okay, let's start by comparing the two integers, -2 and +4. Alright, so we'll start by plotting these on our number line. This will give us a good visual when comparing. Alright, so in order to think about which of these two integers is the greatest of the two, think about which one is located furthest to the right on the number line. Well, because 4 is located to the right of -2, 4 must be greater than -2, right? Which means -2 is less than 4. Or we can write this as 4 is greater than -2. Right, we're saying the same thing. We're saying the same exact thing with these two inequalities. If -2 is less than 4, then 4 must be greater than -2. And keep in mind that when comparing two or more integers, you will always have two ways of writing the inequalities. Alright, let's compare -4 and -7. -4 is located right there. -7 is located right there. Okay, well in this case, -7 is located to the left of -4, so -7 is the smaller number here, right? -4 is located further to the right, which makes it greater. So -4 is greater than -7. Or we can write that as -7 is less than -4. Let's try one more. Let's compare 0 and -6. Okay, 0 is located right there. -6 right there. Okay, so when comparing 0 and -6, well, 0 is located to the right of -6 on the number line. So 0 is the greater of the two integers. So 0 is greater than -6. Or we can say that -6 is less than 0, right? We're saying the same exact thing. Two different ways. Alright. Sometimes you will be required to order a set of integers from either least to greatest or from greatest to least. So let's try a couple of examples where we have to do that. Okay, so let's put the following integers in order from least to greatest. Right, and starting out, until you become somewhat comfortable with this, I recommend that you plot the integers on the number line, because it gives you a good visual to help you compare the numbers. Alright, so let's compare the following integers. Alright, so 5, -3, -1, -7, and 0. Alright, so since we're ordering these integers from least to greatest, let's determine what the smallest integer is out of this, in this set of numbers. Okay, well, the number that's located furthest to the left on the number line is -7. Right, -7 is located further to the left compared to all of the other integers that we've plotted. So -7 would be our smallest integer. Okay, moving from left to right, because remember, as I said before, the integers get greater and greater as we move further and further to the right. Okay, so as we move to the right, our integers will become progressively larger. So to the right of -7, we have -3. So -3 is the next smallest number. After -3, we have -1, followed by 0, and then +5. Okay? Let's do an example where we have to go from greatest to least. Okay. Let's start by plotting these integers on our number line. -4, +6, -7, +4, and +9. Okay, so because we are ordering these integers from greatest to least this time, let's start by determining what the largest integer is. Well, the integer located furthest to the right on the number line is +9. So +9 is the largest integer in this set. Now, as we move from right to left, the integers will become smaller and smaller. Okay, so the next largest integer after 9 would be +6. Alright, so we started with 9. Then we have +6. To the left of 6 we have 4. Right, so the numbers are becoming smaller as we move further to the left. To the left of 4 we have -4. And then we have -7. Okay. The last thing I want to cover in this video lesson is absolute value. Let's talk a little bit about absolute value. When we are talking about the absolute value of a number, we're referring to the distance a number is from 0, regardless of whether it's to the right of 0 or to the left. Okay? And we use these vertical parallel lines to show that we're taking the absolute value of the number. Right? Okay. So if I want to know what the absolute value of -6 is, I'm asking myself, how many spaces from 0 is -6? I don't care that it's on the negative side of the number line. I just care about how many spaces it is from 0. Well, it's 1, 2, 3, 4, 5, 6 spaces away from 0. So the absolute value of -6 is simply 6. What about the absolute value of positive 6? Well, as you can see, positive 6 is also 6 spaces away from 0. And once again, we don't care that it's on the positive side of the number line, right? All we care is the fact that it's 6 spaces from 0. So the absolute value of 6 would also be just 6. Let's try a couple more examples. What would the absolute value of negative 9 be? Well, negative 9 is 9 spaces from 0, so absolute value of negative 9 is 9. What would the absolute value of 3 be? Well, the absolute value of 3 is simply 3. How about the absolute value of, let's say, 0? Well, the absolute value of 0 will always be just 0, right? Because 0 is 0 spaces away from itself. Okay, let's evaluate a few expressions that include absolute value symbols. Okay, let's start with a simple one. 3 plus the absolute value of negative 6. Okay, and when we're evaluating expressions that include absolute value, we will always evaluate what's inside the absolute value symbols first. So the absolute value of negative 6 is simply 6. Bringing down the rest of our expression, 3 plus 6 is 9. So 9 is our answer. Let's try a couple more. Negative 2 minus the absolute value of 3 plus 8. Okay, so inside our absolute value symbol, we have 3 plus 8, so we'll evaluate that first. 3 plus 8 is 11. So now we have negative 2 minus the absolute value of 11. Well, the absolute value of 11 is simply 11. Bringing down the rest of our expression, negative 2 minus 11 is negative 13. Let's try one more. Let's evaluate the expression 8 plus the absolute value of 3 plus x if x equals 4. Okay, so plugging in 4 for x. Inside our absolute value symbols, we have 3 plus 4, so we'll evaluate that first. 3 plus 4 is 7. Right, so we now have 8 plus the absolute value of 7. The absolute value of 7 is simply 7, and 8 plus 7 equals 15.